All right, so hello everyone. Thank you for attending the webinar today. My name is Dhruv Singhal, and I'm the founder of Open Years, as well as a sophomore at Matia Valley High School in Aurora, Illinois. It's great to see that many of you attendees are interested in listening to the speaker today. And I believe that through this event, you will learn a lot about one of the career paths you can take in STEM. Now, before I go ahead and introduce today's speaker, I want to briefly talk about why I founded Open Gears. Before I was a student in Matia Valley, I attended the John C. Dunham STEM School for 5 years, where I engaged in unique hands-on experiences, field trips, and guest speaker presentations. Being able to participate in these experiences exposed me to several specific STEM fields which helped create my interest in STEM. However, there's so many STEM fields out there that trying to decide a STEM direction out of hundreds of possibilities is daunting. So many students have no idea of what they want to pursue, thus forcing them to hop from one major to another until they find a major that suits them right. Did you know that according to statistics, more than half of college undergraduate students change their major? It's quite surprising, and I personally have been struggling to decide what STEM direction to pursue. And I know that there's so many other people out there sharing the same problem. And with COVID-19 affecting our lives, it's become much harder to physically connect with others to learn about different careers. Thus, through Open Gears, I hope to alleviate this dilemma by hosting webinars and events with leaders and college students in STEM. So students and even parents have the opportunity to learn more about different career paths virtually. I hope that this event, as well as our upcoming events, will positively impact you and provide you with insight into several STEM careers. Now, just a heads up here, on September 21st, we will be hosting our second event, this time with scientist Brian Sneed from Cabot Microelectronics. The form is on the website, so if you are interested, after this event, you can sign up. Now, to begin, I would like to introduce our very first speaker of Open Gears, Jake Lynch, a product development engineer at Cabot Microelectronics Corporation, to share about his career and education path. As you may know from the event description, Jake is a chemical engineering graduate from Purdue University with 2 years of experience working as an engineer at Cabot. All right, thank you, Jake, for taking time out of your busy schedule to help inspire students to pursue your STEM career. Everyone, please give Jake a warm virtual round of applause.
All right, thank you for the introduction. Virtual applause, fantastic. Drew, do you know if everyone is from Matia Valley High School? Just trying to get a general idea if everyone.
What's the name? What's the name?
Is everyone from Matia Valley High School?
I am from Matia Valley High School. There are some people in this webinar who are from like Niqua or Obanzi and from other schools. So not everyone's from Matia. So it's a little.
All right. Just trying to get a basic understanding of the group.
Mm-hmm.
Oh, and Joseph is a teacher in Aurora. Okay, very cool, Joseph. So I'm kind of just gonna go off the questionnaire that you sent just to clarify if everything was good. I'm just gonna use that as a small test manager to make sure I'm telling the story correctly. But so if you can't tell, I'm wearing gold and black. So I went to a little hard to say, but Purdue University, and that was in West Lafayette, Indiana. The reason why I went to Purdue in the first place was to study chemical engineering right off the bat. And that is because my father was an electrical engineer and his father was a mechanical engineer. So I decided to study chemical engineering because I wanted a challenge. Small joke, you don't have to laugh. I don't dance, but that's all the entertainment you'll get. So the reason why I chose engineering just because I wouldn't say I was amazing or really gifted, but I understood math and I was able to, if I was studying, just keep my head down. I could just get by with math and science. Classes like history or English, they were fine in high school for me, but they didn't have the same appeal. And then chemistry just really turned it around for me. So what I first thought when I went to study chemical engineering is that it was going to be mostly just talking about how two atoms or two different molecules come together and they form one component, but that's totally wrong. Almost all engineering is basically physics, and then depending on what discipline you go into, that's just going to be how your physics is tweaked a little bit. So in chemical engineering, the chemistry portion is important, but it's not the primary objective. Really, it's how to understand that a certain molecule is going to travel down the pipe. And when I say molecule, really we're always talking about different fluids. And for chemical engineering, a fluid can be not just a liquid, but it can also be a gas. So you want to think of that liquid or gas as a sphere. And then the idea is, well, how does that sphere travel down the pipe through a pump? What happens when it sees valves? And then the more of the physics aspect is, well, as the sphere has different meetings with either elbows or valves, what happens to that sphere? How fast is it going to go? What happens to that pressure? So that's what I learned maybe the first year, and it was just a huge change onto my part of what I was thinking. If I wanted to stay more of the chemistry route, I probably would have been a chemist, but I definitely did like engineering a lot more, and I knew that I would have a lot more opportunities to be a chemical engineer. So that's why I just decided to stay a chemical engineer. But for me, I didn't get to go right into engineering when I joined Purdue. Purdue has a nice program, and many universities are quite similar, where your first year is going to be our general studies. So at Purdue University, it was definitely your general studies, but then also you took your first year engineering courses, and I didn't get to take those my first semester like the rest of my class. I actually had to be undecided because there was not enough room in engineering. So after the first semester, the term at Purdue was CODO. So I CODOed into the engineering program. So I was a semester behind. And then when I got to my second year, first semester, even though all the other kids were just taking one chemical engineering class, I did that one chemical engineering class in my second semester of first year engineering. So I had to do a lot of catch up, but it's okay in your second year of chemical engineering. You can definitely catch up. Usually all engineering disciplines have kind of 1 year in your studies where that's going to be the year that suck. It's not going to be fun. You're not going to talk to a lot of friends. For chemical engineers, kind of around the world, that it's your third year. You might have 3 to 4 chemical engineering classes. You might be taking 1 to 2 different math courses. And then really your extracurriculars or maybe just whatever your hobby is at that moment, what you really enjoy doing. So for me at the time, it was going to the gym. So there were times where I would go to the class and then come home, drop all my stuff off, go to the gym, or vice versa, go to the gym first and then come back, shower, class. And then that's all I did for that third year. for the fourth year, my senior year, it's much easier. You had, or I should say, I had some design courses as well as I don't know what they call it. Maybe some background courses to plan my concentration, because my primary degree was a Bachelor of Science in Chemical Engineering, but I got a concentration in biochemical engineering because I was really interested on not just the chemistry aspects, but it was chemistry in the body. So I was really interested in two different fields, and the first field was pharmaceuticals, and you could all say like, oh, that's something really noble to go into. But the second interest of mine was definitely home brewing. And no, drinking alcohol is probably not the best passion I have, but the science of it is just so simple. It's how do you extract sugars, and then how do you take those sugars and then a little yeast, and then how does that yeast then eat the sugars, produce carbon dioxide and also ethanol. And to me, that was just very fascinating. And then what was great about the whole brewing process is that it was chemistry and it was chemical engineering. So the chemical engineering side is, when do you add in water? How do you move the whole solution into a chiller? How do you heat up or chill down that solution, and then moving it in the fermenter tank? Just what does your tank have to be designed as? What's it going to look like in the future? I thought that was very cool. And moving everything from point A to point B to point C, using a different pump, just how do you figure all that out? So I saw brewing and definitely pharmaceuticals as just a great thing to try to get into. So it kind of leads into one of my first internships. So I was an apprentice brewer in my hometown, which was Sparta, New Jersey, and I brewed beer maybe 2 to 3 times per month, and that's because the beer itself has to ferment for 2 weeks before you can move on to the next batch. And there's only 3 fermenters, so you can't really just start making beer as fast as possible. There was always some sort of wait time. And then going into my next internship, I was a chemist in a company called Eurofins, and you might see them. Eurofins is a very big third-party tester of a lot of pharmaceuticals. So I got to test all sorts of cool drugs, but some of the drugs that we would test were for Alzheimer's patients. So if you're an Alzheimer's patient, obviously you might forget. So the drug that we were trying to test was, after you ingest the drug and it dissolves in some sort of amount of time, it has a small circuit, which you can think of as a battery. And then because that pill has now dissolved, that battery is no longer going to keep a circuit. It's going to break. And then as soon as it breaks, the doctor on the receiving end would see that you've taken the pill on a certain day. So that's a way for Alzheimer's patients and their doctors to kind of keep track that even though you might not have the best memory, we're able to make sure that you take everything at a specific time or day. So it's definitely interesting to see both sides. And even though working at Eurofins was all about the chemistry, it was just, I didn't realize it at first, but I was developing a lot of hard skills. So some of those skills would be using dissolution tanks, and other hard skills were simply just making solutions in a volumetric flask. So there would be days where you can make a couple of hundred mils here and there, and then there would be a day where you make 20 liters. And you got to think about what's the batch size, and then if this is the final concentration, and then it comes in at some sort of raw material assay, because not everything comes in at 100%. How do you dose that correctly so that you're still getting the same amount of concentration at the end? So after those two internships, those were probably done my junior year. For my senior year, after that finished, I actually did one more internship, and that was in California, and I was actually a process engineer for a stormwater treatment project. And the whole goal around that was we were working on the site where a steel manufacturer would make these huge steel pieces for aircraft carriers. And then you let the different pieces anneal over time. So literally, you're just letting the pieces sit outside and get rained on so that the steel pieces themselves could harden and they could really just cool down on their own. And even though it was a good option for the company, it's like, oh, we're getting the water every once in a while. It's going to be like a free way to cool our pieces. Even though that's smart in one aspect, it's actually really bad for the environment. So if you can imagine, as the water hits the metal piece, it is washing all the steel pieces and dirt and grime and grease that are also on the ground, and it puts it right into the storm water, and then that eventually makes its way to the ocean. So the EPA kind of frowns on that when you say, like, this is my great idea. So they actually came to our company, which was called MC Squared at that time. The MC was just the initial, I wouldn't say the initials, but it was the name of the guy who owned the company. So the guy's name was like Matthew McCullough. So I don't know why the C is squared, but MC Squared is what he chose. And the whole point of that project was, how do we take the water before it goes into storm water, clean it up, get all the grease and grime out, get all the metals out, and then send it back down the storm water so it can go to the ocean. So what we ended up doing was just creating another basin. Then we added 2 sumps, and a sump is just a submersible pump. I don't know if everyone knows this. I definitely didn't when I learned.
Pump? Were you saying
What?
sump? Like, I'm trying to describe what a sump is, like SUMP.
Oh, yeah, so SUMP. So it's spelled like pump, but there's an S instead.
Yeah, just wait.
So for that project, the sumps would pump your dirty water through some filters. Obviously, that's going to grab your leaves and your straws and your chip bags, just kind of take some general things out. And then next we had some granular activated carbon, which is really good for getting rid of the grease. And then after that, the fluid would go through some ion exchange resin. So it first went through a cation exchange and then anion exchange. And those resins, ion exchange resins, what they would do is that, for example, if it was cation, it's going to take a cation and then replace it with another cation. So typically it's going to take something like sodium and then exchange it with hydrogen. There's a lot of magnesium on the ground. So magnesium has a cationic charge of 2+. So every magnesium ion it would give 2 hydrogen ions. for an example. Then going through an anion and gradually now just taking things like chlorine or nitrates, and then all depending on what the valence electron charge is, that's how many it's replacing. For every chlorine, it might be giving back one hydroxide. So if one tank is giving just a hydrogen H plus and the next tank is OH minus, well, now you have a bunch of H and OH swimming around, so you're producing water eventually. And none of the EPA is formed with whatever you dump into the ocean if you go that route. What else do I have? Okay. So, after that internship in California, it was difficult for me to find a job. It was not only very competitive, but I didn't do this on purpose, but I definitely graduated during the year of market crashing, and then some stock prices really rising, or sorry, not stock prices, but oil prices really rising. And then when that occurs, really no one's hiring because everyone's just trying to keep the money for themselves. So it's difficult to find a job. So I thought about, well, do I want to spend 3 to 6 months trying to find a second job, or what are my other options? So I actually thought about graduate school, and I was trying to go back to graduate school so that possibly I could do a little bit more in the pharmaceutical industry, or I could just advance myself a little bit more in chemical engineering wise. So I applied to many different schools, but towards the end, I think I was accepted to private schools. And the best university was just actually going back to Purdue University. Plus, my girlfriend at the time became my fiance, and then obviously now she's my wife. So going back to Purdue, since she was also at Purdue for her master's, which was kind of a win-win situation for me. So I went to Purdue, and I got my master's of science in chemical engineering, and got my minor in pharmaceutical engineering. Probably my favorite courses during that time was I took some more biochemistry courses, but I took a lot of pharmaceutical engineering processes. And kind of what I've realized during my internships is, even though you might have one degree, you don't have to follow that degree and just stay there all the time. Like I did chemical engineering with brewing, but then I also did chemistry with that composition. Then I went back to chemical engineering. So don't feel like because you're a mechanical engineer, you have to sit there and only do ME stuff. You can definitely be a mechanical engineer, then do chemical engineering, or you can go into business. You can do whatever you want. Definitely don't kill yourself now in high school trying to figure out what you want to study in college. Definitely high school is a great opportunity to go on field trips just to see other people's jobs and just get an idea of what are the different fields and industries out there. You all want to stay in STEM, but there are at least 4 different opportunities to go into them. So definitely science, math, engineering, tech. So I definitely spend this time in high school where, let's say, science looks really cool to you. Being a chemist, biologist, a botanist is really cool, but you've never looked at mathematics, and maybe you just want to look at that for a little bit. I had a math professor who, this this guy was crazy because every time I'd ask him a question, she was like, I don't know, it's like A plus B equals C, so you're totally fine, don't worry about it. And I asked him this one question, and he actually just responded back, it's like, well, mathematics is like black magic. Sometimes you just throw stuff in, and then you don't know it comes back out. It's like, fantastic. I'm so glad I'm taking this course. That was the time during matrix and linear algebra. So you're really not using numbers anymore. You're using letters during that time, so it's a little bit difficult when you're doing linear algebra. What else do I need to talk about? Oh, okay. So when you can take an extracurricular, definitely do take it. So my extracurriculars, one of them that I mentioned was going to gym, and I did some powerlifting as well when I was in college. So then I was able to find a group of guys, and then from the gym and create an entrepreneur group, and then I also found a different set of guys in my chemistry classes, and I convinced them to homebrew with me. So, and then having entrepreneuring and homebrewing, well, I just had two different avenues to do anything I wanted. So I would create the homebrewing group up. And it was a homebrewing association where we didn't just go to bars and drink, but we also invited different people to come along and just try out different brewing recipes and just get an idea of what's the best combination of different sugars and malts. Okay. So, trying to look at the rest of the work. So, is chemical engineering, is that a growing field? I would say it is. Like with any engineering course, it's always growing. And chemical engineers, I'm going to be a little bit biased, but I'm going to say definitely is the hardest engineering out there. And you're not really taught of how to be the best engineer for how do you do simple addition or subtraction, or how do you just take two components and figure out what the final form is going to be. What a chemical engineer really does is they're kind of taught to think outside the box. So a chemical engineer is really good in the research field. So even though that's not one of the letters in STEM, it's kind of part of science, I would say. Research is just a great opportunity. So you could study chemical engineering, but then you're always kind of taught with the mentality of needing to figure out, well, why does this occur? It's super cool that the mouse can move the different screens on my computer, but why does the mouse do that? And then a chemical engineer would spend the time to open up the mouse and figure out that there are different lasers kind of tracking the movements that you have with the mouse, and you spend that amount of time to do a little research on your own, and maybe you think to yourself, oh, well, that technology can go somewhere else, like maybe it can go into shoes, and you somehow think about it. If you had tried in shoes, how's that going to help someone else, or how's that going to help yourself? You just want to make it for yourself. But how do you have a lot of questions?
Yeah, I mean, I think that's interesting, Jake. Yeah, that it's in your opinion, you found it to be quite challenging, and then yeah, there is a lot of opportunities in research and chemical engineering. Could you elaborate a little bit on the different research opportunities you could do as a chemical engineer?
Yeah, so the obvious things are whatever you're interested in, and pharmaceuticals was a big thing for myself. But some things that I actually had ended up doing because in your senior year of chemical engineering, you do some design work, and that has a little bit of research opportunity. So for our project, it was how to design a battery. And then this battery had to be able to sustain itself and to recharge itself and then pump out energy. So it's constantly moving. And then I knew nothing about batteries in the beginning, but then you start looking up lithium ion battery and then going into a first like a 9-volt battery and just trying to get like where are the pros and cons of each. And if you thought about your battery, how big does it have to be on a scale like that? So I think towards the end, we had designed some battery that was, I don't want to lie to you, but it might have been some crazy like in a 1,000 square foot building. And the issue that we all know with the energy is neither created nor destroyed. So you have to get some amount of energy just for it to start moving on its own. So you're trying to think about what's the easiest way to get that small amount of energy so that it can just move on its own. But besides batteries, pharmaceuticals, you can do research into just about anything that includes a pipe and some sort of fluid. And again, that's a liquid or a gas. For myself, when I say that, and for you guys, I just want to reiterate that chemistry has different definitions, but so anything that has a pipe, so I would say solar power and just creating solar cells, that'd be great for me for research. How do you get gum, GUM gum, to go from point A to point B in a candy factory? It may not seem like it's really interesting right now, but gum is actually probably more of a liquid when you heat it up because its viscoelastic properties are going to shrink. And then as it definitely cools to room temperature, it might become a little bit more sticky and hard to handle. So you'd go through the research opportunity of, well, if I want to move something that's sticky, how hot do I have to get it to actually move through the pipe? And then you might also do research into what materials are even compatible with whatever you're trying to move. And I guess we'll move on to my job.
Right.
So obviously I'm a product development engineer for Cabot Microelectronics. And I think you mentioned that you're going to hear a talk from Brian Sneed, also from Cabot Microelectronics.
The event that I will be doing with Brian Sneed will be on September 21st. That's 20 days from now.
But Brian is a great guy. He is very smart in what he does at Cabot Microelectronics, and he will definitely mention this again. But the whole point of our company is all about chemical mechanical planarization, or CMP. And that's just a fancy term to say, how do you have ridges and then get everything flat? And Why do you want everything flat? Well, if you're making a wafer computer chip, so all the products that I work on and then have sold to customers are different slurries, and they are usually for tungsten metals. And the goal is, how do you put that slurry on a tungsten metal and then get something to polish it just a little bit, like wax on, wax off kind of motion, and then turn that topography ridge-like mountainous zone into a nice plain flat field. And it's important because computer chips, I don't want to lie to you and say they were this big, but Moore's law is, as time goes on, the computer chip has to get smaller and smaller. So as the computer chip is shrinking, definitely all of our different slurries and technologies have to become way more advanced and way more controlled. So we work at the nanometer level. So if you thought about that for how do you look at the nanometer in terms of Earth? Because it's such a crazy number to think about. But it's actually for a grain of sand on top of planet Earth. So we're working at the sand on the beach level as if the chip was the size of Earth.
Jake, could you clarify what a slurry is so that the audience understands?
Yes.
Slurry? Yeah.
So a slurry is just any solution, but it becomes slurry when it has some sort of particle. The particle doesn't have to be floating in a specific way or made out of any material. It's just once you know I have the liquid and a solid in one thing, it's called slurry.
Okay.
For tungsten slurries, our particle is silica, which is really just sand. So we have we make solutions of sandy water that we can throw onto tungsten metal, and because we had different rate enhancers, particle stabilizers, topo correctors, we had different things part of our slurry that it really helps with getting the correct nanometers. So we care about how fast the rate is, and the customer wants the rate as fast as possible. They want to have no defects, no scratches. So a lot of the times you might say, like, well, the goal is to get 5,000 angstroms per minute, which is very fast. I think maybe a different number. But then a lot of tungsten metal is kind of combined with a material called TIOS, and usually the customer doesn't want to polish TIOS, so you might have a rate that's extremely high, like 5,000, but the TIOS removal rate has to be 10 to 20 angstroms per minute. So it's all about how to fine-tune which different components and how much of a percent solid do you have in each slurry. Now, as a chemical engineer, what I feel like what I do a lot of now is I do a lot of separations work. So we get all of our particles and raw materials already in a solution. Then the supplier of like those particles, they would use a ball mill, and maybe sometimes the ball mill breaks, and that's going to contaminate our particle in our slurry, and it might create some polishing issues. So part of product development is how do you design a product so that it could have this great rate to do whatever it needs to for the customer, But then how do you keep that quality in a sustainable area over time, especially when suppliers make small mistakes here and there? So I mentioned separations. So they could be adding in weird contaminants, or just because a ball mill breaks, some extra ions might go in. And so they could filter, and then the filter is going to capture the bigger pieces of the ball mill that broke, but it's not going to capture the random lithium ion that's flowing around, or the magnesium that's flowing around. So I do a lot of ion exchange and ultrafiltration. Those are different separation processes. Ion exchange that I explained earlier is kind of the most simplest technique, but you have to, for a little bit amount of energy, you're taking one ion and then replacing it with another ion. For ultrafiltration, you have to give a huge amount of energy, but I can remove all the ions, have no selectivity, but I don't have to replace it with anything, which is kind of a great thing because I don't have to say, well, I just added a bunch of hydrogen ions, which would definitely affect the pH, which might be a stabilization issue, not just for the particle as it sits in there, but for the product down the line. Probably the most challenging thing about being a product development engineer is, and being in my position at the company, is just working with people who are outside the U.S. So definitely math and science is a very straightforward language. Everyone understands that 1 + 1 = 2. So it's easy when you want to show someone and prove to them why pump A might be a better choice than pump B if you're going to mass produce something. But when you're trying to get your point across about how they need to talk to the customer, or if you want to hear the customer's issues, and that customer's originally from Korea, Taiwan, then becomes a little bit of a communication barrier. And definitely just trying to get your point across is I wouldn't say it's a struggle, but it's just something that I'm always trying to work on. And that's, if I live with anything in this talk with you guys, it would definitely just make sure your communication skills are as high as possible. I would say communication is kind of a soft and a hard skill, because when you're in the field, you might do some math on the ground really quick to show someone some geometry about why it'd be easier to flow and then hit this bend or this angle. That would be an example of how communication could be a hard skill. But then a soft skill communication example would be writing an email, something simple like that. And the best way of trying to convey all your ideas with the shortest amount of words as possible, because obviously the more words you have, the harder of a message is going to be interpreted.
Yeah, I agree with you that communication is a good skill to have.
I'm sorry, what was that?
No, I was saying that I agree with you that communication is a good skill to have now these days. It's like, as you said, that it's trouble to communicate with one person who's all the way in somewhere in a country that is far away. So I agree.
Yeah. So some more skills to have, definitely work on your soft skills. So everyone's going to be proficient in Excel, PowerPoint, Word. all the Microsoft platforms. So you might as well become proficient at this as well. If you're going to be engineering, there are definitely some engineering programs that you want to work and develop on to be more just soft skill oriented. And anytime you can, I'm sorry, what was that?
Would you like to share some advice for students who want to pursue the path that you took? Any general advice?
General advice.
Anything maybe related specific to chemical engineering, maybe just anything in general.
Yeah, so definitely don't feel that you have to choose what I did or follow my path. Kind of the best thing for me was I hate redoing work, so make sure you save everything. It's kind of like the first, even though it's a very simple skill, it's kind of the best skill to save time, because you want to be as efficient as possible with not just your time, but the time of the build that you're working for. And what you should try to do, I'm not saying do this all the time, but you always want to under-promise and then overachieve. So, for example, someone might ask like, oh, can you test out this separation? I'm curious to see if it works. And then you say, yeah, of course I can do that. It might take me 2 weeks. But then you can do it in about a week and a half. Then you shoot to get it done in 1 week. So when you come back and it's done in 1 week to a week and a half, that guy's going to be, wow, this person really cares about me. He got my project done right away. It's kind of the best. That's what this boss might be thinking. But on your side, you're like, that is walking in the park for me. Just doing normal things.
Yeah, I think that's great advice, Jake. Audience, do you guys have any questions for Jake, our presenter? If you have any questions, either you can unmute yourself or you can type it in the chat box. I want to open up these last 10 minutes for questions. All right, no questions? All right, well, I have some questions for you, Jake. So between your bachelor's degree in chemical engineering and your master's program, like what was the difference in the content that was taught?
Yeah, so for the master's program, I definitely I had a little bit more freedom about what I got to choose to study. I was like silly to do some chemical engineering related things. I just can't study art for my master's. But definitely what I realized in my master's, it's a lot more statistics based. So I became really heavy and really focused on statistics. And I happen to like statistics a little bit more now. And definitely at my job, I brought statistics with me. So I got my green belt right away. I'm working towards my black belt for Six Sigma. That's something I would really emphasize that you should all do. Just not get into statistics, but when you finally do get a job, push for that green belt or that black belt.
Could you explain what those certifications are? The Six Sigma and the green belt and black belt?
So in Six Sigma, you could be a green belt or a black belt. So they were the same for the same program. And then both of the courses are just ways of understanding how to get the project done. And you work on different things like project management and team leadership. And definitely statistics has a huge role And depending on what kind of project you're doing, you're trying to build something from the ground up, something that was never there before, and you're trying to build the method, or you're trying to optimize the method. So you're trying to tweak something here or there so it can just run faster.
Yeah, I see. So are there any technologies or any programming languages that you need to know? Any like other hard skills?
Yeah, so program is probably not as important, but if you felt that you were slightly faster in using MATLAB or VPython or R squared than you were in Excel, then definitely I would say just really polish your skills for that, because anytime you have an internship, you're going to say, well, I am proficient in Excel like everyone else is, but I can do that in 20 different other things in R squared. And just having the knowledge of like a very simplistic Excel language and another program language like MATLAB is going to definitely get you farther in life.
All right, yep, thank you. Could you describe a typical work day of yours?
Yeah, so definitely during this time with COVID, the first thing that you think about is safety, but the company is very safety oriented, so it's not too difficult because you're going to see your coworkers performing kind of the same actions. But if we push out to the side, really what my job is kind of like problem solving. So someone comes up to me and says, well, we were producing this and now we can't produce it the same way. Why? And my first two questions is always like, well, you're not getting the same production as before. Is that a problem? And then the next question is, how do you know it's a problem? Because you want someone to be able to define for you what the problem is and where it's going. Otherwise, you have to do kind of that problem definition for yourself, and that's very difficult. You have to have more of a understanding of what they're trying to achieve. But after defining different problems for myself, or just gathering those questions, I work on filtration work, separation work. I actually run the deionized water and the wastewater systems at our R&D facility. So I have two big processes on my own, and I'm trying to build up a large-scale ultrafiltration process in our high-volume manufacturing building.
All right. Last question, Jake. Throughout your presentation, you've talked about like how all these internships you took at pharmaceutical companies and at that stormwater company helped shape your interest in chemical engineering. Could you talk about some of the internships that high schoolers can take right now related to chemical engineering?
Yeah. So I'm sorry to say this, but I don't know of too many opportunities where you can do a lot of engineering. But definitely, one of my brewing apprentice, that was kind of an engineering aspect and a little bit more chemical engineering. So I wasn't 21 at the time when I was an apprentice working for this guy. So I was still able to do all the different steps and learn what I could without having to sample or try any of the beer. So it wasn't breaking any laws. But actually, when I was in high school, it was all about volunteering from my high school. So I think I had 300 plus hours of volunteer hours. So I did a lot of tutoring, and I did some events like where I had to help out inner city kids just have a good time, relax at the beach or a lake. And that is just a great opportunity to work on skills like communication, trying to communicate with child, or if you're tutoring, how are you trying to get your point across about why someone needs to believe you that 1 + 1 = 2, or A and B is going to create this third component if you're teaching some sort of science.
Yeah. All right. Does the audience have any questions? Any last minute questions? Alrighty. Okay. So.